In this video, we'll go over a couple examples of how to name ionic compounds. Ionic compounds has cation and anion. So here, sodium is the cation, meaning that it's positively charged, and chlorine is the anion, which is negatively charged. In the case of cation, you can just take the element name, as in here, sodium. And for the anion, you take the element name and change the ending to IDE. So chlorine gets changed to chloride. Likewise here, barium is the cation, so you name it as the element name barium, and instead of fluorine, it gets changed to fluoride. The reason why there's two fluorines in this compound is because barium has a charge of 2 and fluorine has a charge of -1, and overall the compound needs to have a charge of 0. So if you forgot how the charges are found, alkaline metal is +1, +2. Over here, halogens are -1 and -2. In element form, they're all neutrally charged, but this metals are really ready to lose that 1 electron to become +1, to become the cation. So these two examples are slightly different than the previous two examples because they contain transition metal. Transition metals are the groups from 3 here to 12. So some transition metals have multiple oxidation states, so it can be different charges according to different times. So what you need to do is figure out the charge according to the anion that you have here, because we know that overall you need to have a charge of 0. So oxygen, if you look at the anion, it has a charge of -2. So copper has +2. Therefore, because copper can have multiple oxidation state, you need to indicate which state this particular compound copper has. So what you need to write down as copper, indicated with the Roman numeral 2, oxide. But then there are some examples of transition metals where you only have one possible charges, one possible oxidation state. In that case, you guys don't need to write down the Roman numeral. An example of it, one of them is right here. Zinc does not need, zinc oxide, and you do not need to indicate zinc with the Roman numeral. The common ones in the transition metals where you do not need the Roman numerals are zinc, cadmium, silver. Those three you should always remember. These examples are slightly different than the other ones because you have polyatomic ions. Polyatomic ions exist as group, and you treat them as a group. So CO3, actually you have to learn all the polyatomic ions, has a charge of 2-. This entire thing has a charge of 2-. So calcium, do we need the Roman numeral or not? Calcium is alkaline earth metal, which we know that in the ionic form it has a charge of +2. So we don't need to indicate with the Roman numeral. It's not a transition metal, so it's calcium carbonate. One way to tell whether you have a polyatomic ion in your compound or not is the starting of a new element is indicated by the capital letter. So if you have you have a cation here, calcium, so C here is capitalized, and then you would have another anion which is capitalized, but in the case of polyatomic ions you will have more than 2. So as in here, because these are grouped and you have several elements in here, so you have C capitalized, O capitalized. So that's one hint where to find out which one contains polyatomic ion. So over here it's iron, Let's look for iron here. Iron is a transition metal, and iron can have multiple different oxidation states. So let's figure out what charge the iron is in this case. How you can figure out, again, is based on the anion. Anion right here is hydroxide. If you have learned the polyatomic ion, you will see that the hydroxide has a -1 charge, and you have 3 of them. So iron has to be +3. Because of the multiple oxidation state that iron can have, you do need a Roman numeral in this case, so it will be iron 3 hydroxide.